Okay, all right. Sorry, let me get your attention. Go ahead and respond to the online poll if you are here. And today our topic is going to be GGplot, and the grammar of graphics. And again, today's stuff is not covered on the midterm exam, but we'll talk about GGplot. I think it's a useful package to use, and we'll see how far we get today. We might continue on 6-week Monday. Okay, so again, we have our midterm exam on Friday. So I see you guys asking good questions on Piazza, answering each other's questions. So that's great. And you know, I hope you guys are able to prepare as well as you can for the midterm. But today we'll talk GGplot. All right, let me have you guys settle down, please. All right, so yeah, go ahead. Okay, so the GG in GGplot stands for Grammar of Graphics, created by this guy Leland Wilkinson, and then implemented into R by Hadley Wickham, basically. Okay, it's a useful platform and system that aligns with the tidyverse. Okay, so the tidyverse, you know, all works in tidy data and things like that. Whereas and the GGplot system works as well. It's not meant to be the be-all, end-all of graphic systems, okay? I still frequently use base graphics, okay? And I'm assuming you guys already have some exposure to base graphics from Stats 20 and things like that. You can still do a lot with base graphics. I still use base graphics all the time. However, GGplot, like the tidyverse, makes some more complicated tasks a lot easier by having a kind of a structured grammar, you know, to take care of our, you know, visualization. Okay. All right, and so the whole concept of this grammar of graphics is that in your data you have values. Okay, they might be numeric values, they might be categorical values, and what we do is we map those values into aesthetic attributes of a visualization. Okay, so for example, if you had a column of height values and a column of weight values, you have two numeric values, and it might make sense to say, well, let's put height on the vertical axis and weight on the x-axis. Okay, and you might put dots up on the screen or something like that, okay, in a scatter plot. And that's fine. If one of your variables is categorical, okay, and the other is, I don't know, well, okay, if you've got just a categorical variable and you have like different kinds of cars and things like that, you might have like sedans and vans and trucks and things like that. You know, you might count up how many cars you have, and you will say, I want to graph the count to the height, and then the vehicle type will get mapped to the x-axis, and we'll put cars on this section of the x-axis, we'll put trucks on this section of the x-axis, we'll put, I don't know, whatever, you know, sports cars on this section of the x-axis. And so you are mapping the category, that variable category of car type, onto the x-axis. Similarly, we can map other attributes to variables as well, or map variables to other attributes as well. So we can say, you know what, let's take another variable such as, I don't know, whatever it might be, to you know, the color of the bar, or let's map it to the shape of our dots or things like that. Okay, and so this the GG system makes it explicit that we are mapping variables to aesthetic attributes. Okay, this is often an implicit thing that's happening when you call just regular old plot and stuff like that in base graphics. but the GGplot system makes that kind of relationship explicit. Okay, and so a lot of this stuff comes from, there's a book from O'Reilly that you can get, Safari Books Online, ProQuest Safari Books Online, called the R Graphics Cookbook. It's a few years old now, but it's still good, okay? So you can look up the R Graphics Cookbook, and so I guess it's from 2012, which I guess that's now 7 years ago. But anyway, this uses GGplot for a lot of these things. Not everything is done via GGplot, but it's a good reference, this thing, okay? As well as the GGplot just website, okay? So you go to ggplot2.tidyverse.com, and this has a lot of good stuff. Okay, but anyway, I'm taking some data from the package associated with the Graphics Cookbook, the G Cookbook, and there's this thing called simple data, all right? And it's just a matrix with row names and column names, okay? But this is a matrix, and it says A1 and B1 has 10, A2 and B1 has 7, and so on and so forth, okay? So this is just a little matrix there, and you could throw this into the base graphics and say something like, I want a bar plot, and you use the option beside equals true, and it will plot these together, okay? So we can see A1 having a height of 10 and 9, 10 for B1 and 9 for B2, and then as far as A2 goes, we have heights of 7 and 11, so a height of 7 for B1 and a height of 11 for B2, and so on and so forth, okay? If you wanted to group them not by the A variable but the B variable, you can do that, but it requires you to transform your data. And so now we have to kind of put the B's in columns in this way. And so, you know, this is simple with a matrix. You just transpose it. You just call T on this. And then you could do bar plot on the transpose of our simple data. And now we have B1. And we can see, you know, heights of 10, 7, and 12, which is what we have here, 10, 7, and 12. And again here, 9, 11, and 6 gets graphed over here, 9, 11, and 6 for B2. All right. You might then want to create a legend. And I don't know if you've ever tried to make a legend in base graphics in R, but it's not fun, okay? It can be very frustrating and tedious, and you have to kind of specify the exact labels that you want, the list of colors that you want, or the list of line types, and the positioning on the graph. It can be a frustrating experience making legends, and we haven't included any commands to make a legend with base graphics, but that's probably something we would need to include so that we can tell the difference between the black, the gray, and the light gray bars here, okay? All right, and so, and then later on, if we wanted to graph things using a line rather than a bar graphs or a bar plot, we can do this in base graphics, and we would call plot, okay? And then, and you would call plot on basically one of the things, and then if you wanted to add the second line, you would call the function line, okay? So you'd call plot, and then you would call the second line with lines here, okay? And so we would do, you know, plot, you know, the first row in simple data, type equals L, and then we would add lines for the second row in simple data, and type equals L, okay? And this plots this, but there's a few things going on, right? So the x-axis uses the index, which just goes 1, 2, 3, but it treats it as a numeric variable, and so you know, the default tick marks will kind of put tick marks at 1.5 and 2.5, which don't really make sense in our case, okay? This should be like A1, A2, and A3. and then the blue represents kind of, the black line represents B1 and the blue line represents B2. And an issue here is that this blue line goes off of the chart. It goes down to 6. Okay, and the reason for that is because when you first call plot, that's going to determine the axes that R uses, all right? So it says, well, plot, okay, my data goes from 7, 10, 12. I'm just going to fit my vertical axis to fit 7 through 12, and it does that. But then you add extra data that goes outside of that, and because we've already created the plot, it just says, oh, well, sorry, you're not going to be able to see the end of the point here, okay? So, that's some of the issues, and so then you'd probably, if you were using base graphics, you'd say, I'm cutting off of my data here, so you would have to go back to your command and say plot, and then add in the option, y limits is equal to, 6 to 12 or something like that, all right? Not a big deal, but, that's just something we've got to kind of keep in mind, okay? If we wanted to switch to tidy, if we want to use GGplot, what we have to do is we have to convert our data into tidy form, okay? And this is, maybe one of the biggest detractors of using GGplot is that sometimes the data you get is not in tidy form, and transforming your data into tidy form might be off-putting, and you might say, well, I'm just going to use base graphics, and that's totally fine, okay? If it's just a quick graph that you need and you don't feel like transforming your data, that's fine. You can go ahead and just use base graphics, make the adjustments as necessary. But as you start working with larger data sets and you want to do, have this flexibility in creating your graphics, then it might make sense to go through the effort of transforming your data into tidy form and then using GGplot, okay? So everything in the tidyverse, as its name might suggest, requires your data to be put into tidy form. And so what this means is we need to get our data, we have one column for the A variable, one column for the B variable, and then another column for our values, okay? And so basically, our data originally looks like this matrix, and it's a little deceiving, but these are just row names. These are, instead of having bracket 1 comma to indicate the first row, this is actually just the row name B1 and the row name B2. Okay, so in order to transform it into tidy data, this is what I've done. First I transposed it, okay, and made a called data frame on that. And so if you call a data frame onto a matrix, it just turns it into a data frame, no problem. And then I have to save basically the row names, which are now our A variables, into a new column called AVal, all right? And, well, you can't see it, but then, then we gather the values that are in columns 1 and 2, and we gather them into the column value, and the index is going to be bval, okay? So anyway, once I used gather on this to make our data tidy, this is what we have, okay? We've got A123, B111, and our value is 10, 7, 12, okay? Okay, and now we will make our bar graph, okay? And so what we will do is we are going to map the A variable to the X position, okay? So the A value gets mapped to the X position. So that means on the X axis, I'm going to have one section for A1, a section for A2, and a section for A3, okay? It feels a little strange because these are not numeric, they are categorical, but we're effectively just designating certain spots on the horizontal axis to be for this category, and this category. So we're going to put category A1, on the left, category A2 in the middle, category A3 on the right, okay? We're going to map the B value, whether it's B1 or B2, to the fill color of the bar, all right? And then the Y position of our bars will be determined by the value that appears in this column. Okay, so we're going to say value will be the y thing. Okay, and then we tell it to draw the bars, and this is what we get. Okay, so we have a along the x-axis. The height of the value goes in here, and then the b values determine the color, and it automatically creates a legend for us. Okay. We have a few other things. We have stat equals identity and position equals dodge. This is so that because the default behavior of geom bar is to kind of tally up. It's expecting generally a count of individuals, and it might you might expect some kind of data frame in it, and we would expect like 40 observations to belong to category A or something, and it's going to count up those things. So the default behavior is stat is the count of how many observations have that. But here, because we want it to actually graph the height of the value that appears, we're going to just say stat is equal to identity. Okay. And so again, our data needs to be in tidy form so that each thing that gets mapped to an aesthetic attribute is one of the columns in the data. Okay, so here we're mapping a value to the x, value to the y, and the fill color to be the b value column. Okay, and we graph that. What if I wanted to group it the other way and have b's here, and we would have 3 bars, one for a. So we would have b1 over here, b2 over here, and then we wanted basically within the b1 group we want 3 colors of bars. What would I do?
X equals b val.
X would be b val. Fill would be a val. Okay, all we're doing is we're just changing the aesthetic mapping. Okay, so if we wanted to do that, we just change X to b val, fill to a val over here. And again, we don't have to do any modifications to the data. Okay, we leave the data as is. It's already in tidy form, and we do that, and now we have a new graph here. Okay, so all we've done, it's basically the same command, but we've changed saying b val. The b variable is going to be mapped to the x-axis. And then the fill color is mapped to a val. And again, our legend is automatically updated to show that, whatever pink or red is A1 and green is A2 and blue is A3. Okay. If we wanted to switch to line plots, this is not difficult to do either. Okay. So here I have 2 lines, one line for B1 and a line for B2, okay? And so here I'm saying I'm mapping the A value to the x-axis, okay? And so it just says, okay, well, it's not a numeric thing, it's a categorical thing, but I'm gonna just arrange them in an order that makes sense, which goes A1, A2, and A3. And then on the y-axis, we'll use the value column, and it does that. And then we group our observations together by using group as b-val, and then we say the color of the line is b-val, okay? And then, so this does the aesthetic mapping, and then we just say draw the lines, okay? So here we add geom underscore line. Okay, so all of this, all to say is that the things that change is just we only call a different way to graphically represent our visuals, okay, using the geometries, okay. We note that the Y range is automatically adjusted to fit all the data, okay, because you give it the data up front, and so it automatically fits that. And then the x-axis remains categorical instead of being converted to a numeric thing. Okay, so it doesn't say plot 1, 1.5, 2, or things like that. It remains a categorical thing. So these are just some nice things that GGplot 2 does for us. Okay. All right. So here are just some terms that you will often see in GGplot. Okay, we have the data. This is pretty straightforward. It's got variables, and again, the key is that each variable has its own column. It's in tidy form. Each variable is its own column. If there's something that you want to map to an attribute, an aesthetic attribute, it needs to be in its own column. You can't have GGplot try to use a row or something to keep track of something. Each variable needs to have its own column. As far as geoms go, these are the geometric objects that will represent the data. Okay, so far we've seen bars and lines. Other things that we can use would be points. I'm sorry, and then there's a bunch of other geometries. And as far as we'll get in our class, we'll just look at the bars, the lines, and the points. Okay, and we'll probably get through a little bit of it today, and we'll have to carry on Monday to kind of cover some of these things. But there's a lot more that GGplot is able to do. So I'm just covering the basics here. Okay, and then the aesthetics are the properties of those geometries. Okay, so points have aesthetic attributes like the size of the point, the color of the point, the shape of the point, and the position of the point. Those are all aesthetic attributes. Bars will have aesthetic attributes. The height of the bar, the X position of the bar, you can even change the outline color and the fill color. These are all different, or like the transparency value of the bar. These are all different aesthetic attributes. Lines have attributes. There's not as much you can do with a line, but you can change like whether it's dashed or dotted. That's an aesthetic attribute. So you can say, like male will be a dashed line and female will be a solid line or something like that. Those are aesthetic attributes of these things, okay? And we're basically going to map those values in our data to the aesthetic attributes, okay? Scales control how the mapping goes, all right? So in terms of, you might want to map a numeric attribute to a color of the bar, okay? And so you might say high values will get represented with red and small values will get represented with blue, okay? And now you have a scale where small values will be blue and large values will be red and medium values will be purple, I guess, okay? And but you might have to, and GGplot tries to automatically figure out the scale by going from minimum to maximum, but you also have manual control over how you want that scale to be specified, okay? You might say, small values are black, high values are white, and you're gonna have just some kind of transition of gray as well. That's possible, okay? Meanwhile, guides work the other way. Guides are things like legends and axis labels that help the viewer to then go from the visual representation back to the data representation, okay? So when we create a graphic, we go from the data values onto aesthetic attributes. You need a guide, okay? So just like back here, okay, without any guide, we have no idea what this black or gray or light gray represent, okay? We would need a legend which says black represents this category, gray represents this category, and light gray represents this category, okay? And that serves as a guide. Other things where you have just, if we created a scale where small values are blue and large values are red, it would be appropriate for us to then, in our graphic, include a guide that says red corresponds to values of 100, and blue corresponds to values of 0, and purple is like 50 or something, okay? We would need that so that the viewer can look at the picture and understand that this color represents this value in the data, okay? And so these are key aspects in order to convey information, okay? When we create it, we need to have rules about how our data gets mapped to aesthetic attributes, and when it's presented, we need to provide guides so that the viewer can then kind of get in their brain an idea of what the data looks like by just looking at the visualization. Okay, so those are kind of our terms here, and so here's just a typical graphing scenario, which is that we've got data, numeric or categorical variables, geometries to represent each observation, and an aesthetic, and then a scale, and we define some kind of mapping from the data into the aesthetic space. So here we want the aesthetic attribute to be the y position of the geometry that we're doing, whether it be a bar or a dot. We need to say, how do we go from the numbers to the vertical position? And so a linear scale might say, okay, well, if the smallest value is 0, that's going to show up at the bottom. The biggest value is 10. We're going to put that at the top, and 5 would go in the middle. Okay, but someone else could say, well, these are earthquake things or whatever. I don't know. We need like Richter scale, logarithmic type things. These are all different things that go on. Okay, guides help the viewer, and I've talked about this. So should say a legend is another type of guide. Okay, and that's what we've got. All right. So certain aesthetics only work with categorical variables, such as the shape of a point. Okay, so the shape of a point, you can probably do triangles and circles and squares, or I don't know, maybe little symbols, emojis, or something like that. But that's going to be a categorical thing. Okay. Some things work with categorical or continuous, such as x. All right. The x position, that can work for a continuous numeric variable. It can work for a categorical variable. Even the color can work for both categorical or continuous, right? So you can have continuous ranging from white to black, in gray, shades of gray. You can have the color being, red is this, green is this, and blue is this. Okay, so that can be categorical as well. All right, scatter plots, you got to have kind of numeric things and stuff like that. All right. So I guess you can have scatter plots with categorical things as well. Okay. All right. So when we build a graph, we first call GGplot to initialize an empty plot, and then we declare the aesthetics. Okay, so here I'm just creating not an empty, but a very simple data frame. Okay, all right. This is in tidy form. We've got the x variable in one column, y variable in another column, and a grouping variable in a third column here. Okay. And we can specify our first graph using GGplot, and we'll say I want to take the x variable and map it to the x-axis, and I want to take the y variable, the y value, and map it to the y-axis. Okay, and this creates an empty GGplot. Okay, it creates a plot but without any geometries. All right, and so in this case, it probably makes sense to graph points. All right, and so I would say, okay, let's do GGplot, and then what we want to do is we'll add geom points to represent these things. But all we've done is we're going to say the values in the x value column gets mapped to the x-axis, and the y value column gets mapped to the y. Right now, the group column is not mapped to anything, and so that will not be represented in our visualization. Okay, and so here, when I plot it, this is what it looks like. Okay, it's the same thing. We added point geometries. Points have both an x and a y aesthetic attribute. Okay, and so the points get plotted for each observation using this point's aesthetic attributes are its x and y axis, x and y position, so we get dots at each of these x and y positions. Okay. I can, points have other aesthetic attributes such as the color of the point, okay? And if I want to include the color of the point, I can just map that variable, grouping variable, to the color of the point, okay? So here, we can do it in a few places, okay? I could map it to the aesthetic attributes in GGplot, or I could do it to within GeoPoint, okay? So the points have their aesthetic attributes, such as the color, and we can map that to the group, okay? So here, earlier I created this thing called P, okay? So P is just GGplot, where X is the X value and Y is the Y value. And you can then add geometries by calling P plus the geometry. So here I'm going to say P plus the geometry, point geometry, where group has been mapped to the color, okay? And then, and it's a little hard for you guys to see, but we have blue and red points, and a legend, a guide is created for us so that we know that red corresponds to A and blue corresponds to B. Okay? There's a difference between mappings and settings, okay? Mappings will take a variable in the data and map it to an aesthetic attribute like this, where the group is mapped to the color, okay? On the other hand, we can just say the color is equal to blue. This color no longer represents any attribute in our data, okay? Color is just going to be blue for all of the points, so it no longer represents an attribute in our data. And so this is just called a setting. Things like, if you wanted to change the size of the point does not represent anything in our data, and so that would be a setting. If you map the size of the point to an attribute, then it would be an aesthetic mapping, okay? All right, so here this is just using the setting where the color of the points are blue, and these colors don't represent anything, okay? We just like the color blue. Here we can change the scale manually, all right? So again, I removed the aesthetic attribute for saying the color of the point represents the group, so all of our dots will go back to black again, okay? And here I've changed the limits of the x-axis, and I'm going to say I want it to go from 0 to 8, all right? And so our data, which really goes from just 1 to 4, the x-axis gets changed to 0 to 8, all right? And this, if we wanted to include something over here, we now have space for it or something like that. If perhaps we want to compare this graphic to another graphic that we've produced earlier that contains data that goes from 0 to 8, all right? And so not to be misleading, we might want to use the same horizontal scale on our graphic, even though our graphic doesn't include data that goes up to 8, to compare with another graphic that we produced earlier to go up to 8 or something like that, okay? So there's reasons why you'd want to take over manual control of the graphics there. Okay, there's more to talk about, and we'll cover more of this on Monday. What I want to do, we haven't done this ever since we started class, but I'm going to do a manual attendance roll call here. So just to make sure everybody's